Okay, linear quadratic system. Think what that means. Linear quadratic system is just a system of more than one equation. One's linear, one's quadratic. Big deal, right? So to solve these things algebraically, you can use all the same techniques you use for linear systems. Typically we're probably just going to substitute the most. So if we've got something here like this system is a really easy one. Look, these are already both solved for y, aren't they? So like let's pick this top one to be our substitution equation. Then all we're going to end up doing is just substituting x squared for y in the bottom equation. And we get x squared equals 1. So we get a simple quadratic equation. And then now this transports us back in time to unit 2, and we just solve it the easiest way we can. That's pretty easy. What's my technique for solving that one? Square root, right? I'm just going to isolate x. I can point to a single variable, so therefore I can isolate it. And I isolate it by just square rooting both sides. So what do I get for an answer then? X equals, careful, x equals 2 squared. 1 squared.
I. Negative 1.
No solution.
If x squared equals 1, x equals
1 squared. I squared.
0. 1.
Okay, we're just shooting. Come on, just
1.
well, yeah, square root of 1 is 1. That's part of the solution. But what,
so we add
plus or minus?
Oh my god.
Come on, Connor, why'd you not say that? Like, you always say
You
stupid
made us
stuff.
look like fools.
Come on, Connor.
You
It's all on,
definitely did.
it's all
You're
on.
like,
Don't
talk
about
icon.
icon.
Oh,
I just bragged about period 7. You guys couldn't even saw it. Oh my goodness. So yeah, remember
Remember
the
you the
rule.
whole time.
Remember the rule.
That's fine.
When you square root both sides of an equation, you have to include plus or minus, right? So we get two solutions. We get x equals 1
And negative 1.
or x equals negative 1. But we're solving a system, so we need ordered pairs here, don't we? We need values of both of the variables. So when x is 1, what's y?
It's
One.
plus or minus
Y is 1. Tells us right there, right? So we get the ordered pair, we get the ordered pair x is 1, y is 1, or we get the ordered pair x is negative 1, y is 1, and so that's our solution. Two solutions, two ordered pairs. Okay? If I were to graph these functions, what am I going to get? A parabola intersected by a line, and how many times does the line intersect the parabola?
Right.
Twice. Once at that point and once at that point, right? Okay? Let's try another one. Okay, what about this? So when we're doing problems like this one, linear quadratic system, we want to be a little bit careful about which substitution we make, right? We want to make an easy substitution and not a hard substitution. Skylar, what do you think would be a hard substitution? X or Y?
Y.
How come? True, that's true. So maybe X is easier. Does X seem like a good idea?
No, you did it
Ooh, how come X is even maybe a worse
Didn't
idea?
you get it in a fraction?
Well, yeah, I'd get a fraction for one thing, but even if I didn't, look where the X is. It's inside the quantity that's being squared. I don't want to plug stuff in inside the quantity that's being squared, right? I'm creating extra work for myself. I'd rather make a substitution between, places where I've got variables that are not being squared, right, that are linear, okay? So I'm going to solve for y. It's already done, right? Look right here. There's my substitution equation. I already know what y is. So then all I have to do is take this top equation and plug y in. So I get x plus 3 squared equals negative y. But what's y? Okay? That makes sense.
Okay, so you set the x plus 3 squared equal to negative 3x minus 7 because they both y equal to 1.
Right. I made the substitution, exactly. If y is equal to this, right, then I can trade all this stuff down here. I can trade all that stuff for y in the top equation, right?
You just change the place.
Yeah. I'm literally just substituting. Where I used to have a y, I'm going to substitute that. Okay, but notice that I still have to have that negative outside. How come? Because it's negative y, and that whole thing is y. True. Whenever I make a substitution for something like that, though, if y represents the whole negative 3x minus 7, the whole ball of wax there, right, then I have to put it in parentheses, because that's my mathematical way of saying it's all one thing. We call it a quantity, right? Okay, so now this, it doesn't look super pretty, but it's not horrible. We can do that. How many variables are there in that equation? Only one kind. There's only x's. So if there's only x's in an equation, that's what algebra is for, right? I mean, we can solve that equation. Now think about how it's been a while since we've done a lot of this type of algebra. We did some of this back in Unit 2. But our goal here is to get this into the form of a quadratic equation in standard form, isn't it? Right, we want to get it into this form. We want to get it to the form ax squared plus bx plus c equals 0, right? That's a quadratic equation in standard form. Remember, that is just simplified form. That's all it is. If I just follow PEMDAS, I inevitably am going to end up there at some point. Okay? So let's do that. So I'm going to simplify. So I can get this into a point where I can do something with it, right? So let's follow our steps. First step of PEMDAS, parentheses. Is there anything I can do in parentheses? No. Inside these parentheses, there's nothing I can do. Inside those parentheses, there's nothing I can do. I can just go ahead and cross that one off the list. What about exponents? Yeah, there is an exponent, right? I have something squared. So I have to simplify the exponent first, right? So the first step, first order of business is I've got to know what is x plus 3 squared. Okay? Now do you remember the pattern? We had a really good pattern for this, right? We knew that if we had the pattern a plus b squared, what did that equal? No. A squared plus 2ab plus b squared. Now, officially, we're going to talk about that pattern next unit, but I'm kind of giving you a sneak preview because it's so useful. But you can always just FOIL this out, x plus 3 times x plus 3, but that's kind of a lot of work. I mean, not a lot of work, but it's more work. It's easy to do, but it takes a little time. But think about this. If I just follow this pattern, it's a simple pattern. If I'm squaring out something like a plus b squared, the pattern is just the first term squared plus 2 times the product of the two terms plus the second term squared, right? So what does that look like for this case? X plus 3 squared then would become what?
X squared plus 3 times plus 9.
Good. X squared plus 2 times x times 3 is positive 6x. Good. Plus 3 squared is 9, right? Okay. So then all that stuff is what we get out of this, isn't it? So everything here becomes x squared plus 6x plus 9, and that's all equal to negative the quantity, negative 3x minus 7. Okay, next step. So we did exponents. What's next? Multiply, divide. Is there anything that needs multiplication here?
Yeah.
There it is. I have the negative 1 that I have to multiply by y, which is this whole thing.
Yes.
Right? When I multiply something by a quantity that has multiple terms, I have to distribute, don't I? So I'm going to distribute the negative 1 to both of those terms. And what does that give me?
3x plus 7.
Okay, so I end up with, I've got my x squared plus 6x plus 9 equals positive 3x plus 7. Okay, we're getting there. And then finally, last step, addition, subtraction.
X squared plus 3x.
Okay, good. I'm just going to subtract 3x from both sides, subtract 7 from both sides, and we end up with
X squared plus 3x plus 2
equals
is 0.
0. Standard form, right? And now this is classic Unit 2 stuff. Now think what we do in Unit 2. The first example was the easiest kind where we can just isolate x. Can't do that here. We've got x squareds and x's. But what's the next best option if it works? Think about the list we went down in Unit 2. If we couldn't isolate x, what would you try next? See if you can just think of it though. No cheating.
Complete the square.
No, we had a whole bunch, right? So completing the square was, God, I thought, to me that's a little harder, right? What was the easiest thing? Doesn't always work, but
Was it magic number?
magic numbers. We'll try to factor, right? We'll try to factor and use the zero product problem. Good. See, it's coming back. It's been a little while, but it'll come back to you in a hurry. It's like riding a bike. So if we can't isolate x, the first thing we always want to see if we can do is, can we find magic numbers? Now, it's only going to be worth doing if a is equal to 1. If a is not equal to 1, and we can't divide both, if we can't put a equal to 1, then don't even try, right? If a is not equal to 1, we'll just jump down to the bottom and do quadratic formula. But if a is equal to 1, we'll try to find magic numbers. There's sort of an optional second step there. You know, if you can't find magic numbers, if you like completing the square, you can complete the square. But you can always use the quadratic formula, right? Are there magic numbers on this one?
Yes.
Yeah.
There are. 2 and 1.
I can't believe it.
Right? They have to multiply to 2 and add to 3. So x plus 2 and x plus 1. So what are my solutions then?
2 and negative 1.
Ah, okay, so we get x equals negative 2 or x equals negative 1. So we'll just try both those out and see what we get. If x equals negative 2, where are we going to plug it? Well, there's my substitution equation right there, isn't it? Y equals negative 3x minus 7. So I just got to find the y values that go with those x values, right? So here I'm going to get y equals negative 3 times negative 2 minus 7. So 6 minus 7, y equals negative 1. So one solution is the ordered pair x is negative 2, y is negative 1. Or what about over here? Y equals negative 3 times negative 1 minus 7. So that's 3 minus 7 is negative 4. Oh, we got it. Okay, no biggie. One I want to just quickly show you here is something like this. This is no harder. In fact, this is easier. But it looks a little weird because what's the variable that's being squared this time? Y. Big deal. If I were to graph this function up here, instead of this being a regular upward opening parabola, what would that look like, do you know, if the y is being squared in a quadratic function instead of the x's? It's going to look a little weird. It's going to look like this. This function right here is going to open sideways. It's not a function, actually. It violates the vertical line test.
Is that why you ask is true or false in test like we have those? Just like that one, what is false? That's what that class is.
Yeah. Way at the beginning of the year, way long time ago. Yeah.
Does all this when you have to move the y to the other side?
Okay, so the good news is, no, this works exactly the same way as the last step we did. No big deal. So what am I going to do here? Well, we could solve for x and substitute. That's fine. We can do that. So what if we solve for x in the, how about the top equation? If we solve for x, what do we get? All I get is easy to isolate x there. What do I get? X equals
Y squared plus 1.
plus 1. So there's my substitution equation. I'll put a box around it. And then I'm just going to make the substitution. All this stuff is going to go in there wherever I have an x in my other equation. Right? So what's that give me then? it's gonna give me, instead of an x, I'm gonna get y squared plus 1, good, minus 2y equals 1. Now, I didn't put that in parentheses, how come? I could, but it's not necessary. Say it again. Okay, so it's not being taken to a power, good, and it's not being multiplied by anything, right? So I don't need to, okay? So now, all I've got to do is just put that into standard form. That's pretty easy. I'll just subtract 1 from both sides, and I get y squared minus 2y equals 0. That's an easy one, right? So we want to try to, now, okay, we're not going to find magic numbers. We could, but we can factor that even more easily, right? Because when we find magic numbers, really the purpose for doing that is to factor it.
Factor out a y.
Factor out a y. If I've got two terms, I want to factor out a greatest common factor. I can undistribute a y, and what's left over? Ah, good. So what are the solutions then? By the zero product property. Either for the product to equal 0, yeah, good. Either y has to equal 0 or y minus 2 has to equal 0, right? So either y equals 0 or y equals 2. So we get two cases that we need to try. If y equals 0, well then if I plug in 0 up here, what's x? 1. Good, so I get the point 1, 0. If y is, what if y is 2? What's x? 5. So those are my solutions. Okay? Last one, because you're going to get one like this too. So on this one, we'd probably just solve for y in the top one. Agreed? What do you think? Yeah, we wouldn't want to do that because the x is in parentheses. So this is just going to give us y equals negative the quantity x plus 6 squared, right? So if I make my substitution then into the bottom equation, what's going to happen? I'm going to get negative x plus 3 times all this stuff, right? I'm going to get 3 times negative x plus 6 squared. Like that, right? Everybody agree? Okay?
Why is it double?
Well, because I'm multiplying 3 times that whole thing, times everything up there. Right?
So,
Yeah, if I didn't have the other set of parentheses, it'd look like 3 minus something, but it's not. It's 3 times negative quantity x plus 6 squared. Okay? And that whole thing is equal to 15. So now all I've got to do is just simplify this, right? So I'm going to follow order of operations again. So what's the first thing I got to do? Well, it's PEMDAS.
what's your short?
Inside the parentheses, there's nothing to do though, right? Okay? But I got to do an exponent. So my exponent, let's make that the yellow stuff. So this stuff right here is going to become what? Good. X squared plus 2 times x times 6 is 12x plus 36. So I'm going to put that all in parentheses, right? And then I've got the negative out front. So I guess there is something to do in parentheses a little bit. Inside the purple parentheses, what could I do? Distribute. Sure. Okay, good. So then, if we do that, if we distribute inside like that.
So what did you have to do that before you did the exponent?
No, I can't, because I can't distribute over something that's being squared.
Oh.
So inside the, now, it brings up an important point though. We could have really complicated things where inside the parentheses, I could have a jumble of all these different kinds of stuff going on, right? So inside the parentheses, I still have to follow regular order of operations, okay? So then, we've now got, if we make that distribution, we've now got a inside parentheses, we've got a negative x squared minus 12x minus 36, and then outside we've got a positive 3, negative x plus that. Now what? Distribute the 3, good. So we get negative x, that's going to give me a minus 3x squared minus 36x minus 108 equals 15. Now I just combine like terms, right? So negative x and negative 36x, that's going to give me negative 3x squared minus 37x. And if I subtract 15 from both sides, I get minus 123. So that's almost there. What's the one last thing I'd want to do to this? Well, no, but what's wrong with that? What's wrong with A?
There's 3 x's.
A is negative. I want to multiply both sides by negative 1, don't I? To make it positive,
Yes.
right? And change all the signs. So this one would become a positive 3x squared plus 37x plus 123 equals 0, okay? That looks terrible, right? But now keep in mind, if no real solutions exist, enter false, okay? So clearly, this quadratic equation is the nastiest kind. This is the kind where we're going to have to use quadratic formula, right? There's no patterns, we can't factor that in, right? So we'd use our quadratic formula. So quadratic formula, remember, if we have something of the form ax squared plus bx plus c equals 0, x equals c. There we go. Very nice. Good. Very nice. So now, we could plug into that, right? But what's the part of that that's going to tell us if this is real or imaginary? The square root part, right? Because it's the radical. The only way you get an I is if you have a square root of a negative. So this is where we really want to be interested in what that's going to be. If b squared minus 4ac, which is the discriminant, right? If the discriminant is negative, we're done, because the answer is false, right? Well, let's think about this. B squared minus 4ac. B squared is, or B is 37. So 37 squared is going to be something, that's going to be on the order of like, that's going to be somewhere between 1,500. All right. Yeah, that's going to be something on the order of like, a little less than 1,500, right? So what about 4 times A times C? 4 times A, that's 12 times 123. Think about that. 12 times 123. Like if we do the math on that, what are we going to get? Are you sure?
Oh, it's minus?
I don't
No,
think
you
so.
get it. You get it.
B squared minus 4AC, right? So what is the discriminant going to be? Somebody just do this on your phone. 37 squared minus 4 times 3 times 123. What is that?
13 squared is 1,369.
Okay.
1,369 is 37 squared.
Okay.
Negative 107.
Okay.
So it's negative.
So that would be false.
It's negative.
No true.
So you would do all that work just to find out it's negative?
Yep.
I mean, false.
Yeah, to find out it's false. But at least we didn't try to simplify this whole thing, right? You see why it makes sense to start with the part that's under the radical. If it's positive, then you just keep going and finish the job. But if it's negative, you can stop, right? So we know right there that this is imaginary solutions. Let's say non-real solutions. And so the answer is false, right? Okay, makes sense? We're done.
It's all in our heads now.
Yep.
This is now becoming an innate part of our lives.
I feel like I can do it